Now let's take a look at error handling in Swift. You represent errors using any type that adopts the error protocol. Here in this example, we have created an enum printer error that adopts error protocol. If we look at the definition of the error protocol, we can see it has no body. It is a marker interface or protocol which has no code written in the body. Use throw keyword to throw an error and throws keyword to mark a function that can throw an error. Here we can see in this example, we have a function send that has declared that it can throw an error using the throws keyword. And on line 15, we are throwing an error, printer error, with a specific state. We created printer error enum on line 5 above. If you throw an error in a function, the function returns immediately and the code that called the function handles the error. Here on line 15, we are throwing an error and the subsequent lines of code will not be executed. And the code that called the function will have to handle the error. There are several ways to handle errors. One way is to use do catch. Inside the do block, you mark code that can throw an error by writing try in front of it. Here inside the do block, we have specified try keyword in front of send function, which has potential to throw an error, as indicated above by throws keyword. Inside the catch block, the error is automatically given the name error unless you give it a different name. Here we can see inside the catch block, the thrown instance of printer error is available in the label error. You can provide multiple catch blocks that handle specific errors. You write a pattern after catch, just as you do after case in switch. Here we can see that the do catch syntax is similar to switch case syntax we have seen before. And we can write patterns after catch similar to the pattern we have seen in switch case. Another way to handle errors is to use try ? to convert the result to an optional. If the function throws an error, the specific error is discarded and the result is nil. Otherwise, the result is an optional containing the value that the function returned. Let's quickly review the send function. The send function takes a job number in the form of integer and a printer name. If the printer name is never has toner, it throws an error, else it returns job sent. Now here we are calling send function at two different places. On line 50, based on the arguments applied, the result is job sent, as can be seen on the right hand side. And on line 55, since we sent the argument never has toner, an error will be thrown. The returned error will be an optional string, since the send function returns a string, and by adding this try ? the return type will be of optional type. And since an error is thrown on line 51, the returned value will be nil, as can be seen on the right hand side. This approach can be useful where we do not want to know about the details of the error, but only want to know whether a function call executed without any issues. Use defer to write a block of code that is executed after all other code in the function, just before the function returns. The code is executed regardless of whether the function throws an error. You can use defer to write setup and cleanup code next to each other, even though they need to be executed at different times. In the function, fridge contains food. In the first line of code, we are setting up a value for the constant fridge is open to be true, but we want to ensure that before the function exits, we want to set this variable to false. So we write this kind of cleanup code within the defer block. The setup code and the cleanup code are written next to each other, which is useful from the maintenance perspective of the code. The code written within defer block is executed even if the function throws an error.